Hey guys, this side Anirudh. I'll be your trainer today. So we have few sessions that we already gone through for BGP. So welcome to the next session. Let's go on.
Soft reconfiguration for a neighbor, then you will create a separate table for received prefixes, and you will be having all those prefixes in that table. So if you want to allow anything in your distribute list, in your prefix list, or you deny, it will get refreshed or it will be updated via with the help of that received prefixes table only. It will not require to send a request, route refresh request towards its neighbors. So I hope that you people have understood the uses of soft reconfiguration. It is just to reduce the overhead of neighbors, but you must have enough memory. So generally in production you will not see this feature enabled. Have you understood it or not? Fine guys. After soft reconfiguration, what? The soft reconfiguration? No, it's not possible. There is no command, there is no global command in BGP to enable it globally. 65500 see BGP soft reconfiguration, nothing. Soft reconfig backup is there. I don't know what is the uses of this command. Just wait. Okay, you can. Oh, it's possible. You can also configure this command, soft reconfig backup. It will also work same as that you configured per neighbor, right? This is in global mode, router mode. You are not applying it for particular neighbor. This time it will be applied for all neighbors. Fine guys. So this is all about the software configuration. Then after it, you can also use one keyword like remove private AS. Allow AS in. I hope that you people understand what is the uses of allow AS in. Like if you are receiving prefixes with your own AS, you will discard them. But if you want to allow them, you have to say for that neighbor you can say allow AS in. With using command, like if you are on New York router is receiving some prefixes with same AS which are coming from BT. So we can also configure this command as well, like 1000 neighbor 80.1.1 allow AS in. That's it. After running this command, it will also start to allow those prefixes which are containing our own ASs. So that is the meaning by allow AS in keyword. Apart from it, we can also use one remove private AS keyword as well. Remove private AS. Let's say that I'm an ISP actually. Let's say I am an ISP and I am connected with my customer. Customer is advertising prefixes with using private AS. Then ISP1 is giving those prefixes towards ISP2. Now remember that when one ISP will advertise those prefixes towards another ISP, you will never advertise those prefixes with private ASs. So let's say this time we do not have any connection in between R5 and Sprint US. So move on R5. Router BGP 65500 do show IP BGP summary neighbor. Just shut it down. So and move back again on BT, and here I shut down that neighbor. Just no shut it. 35500 neighbor 101.1.1 shut down. Say no. So it will come up. Neighborship will come up now. So fine. So now Sprint US will start to receive these prefixes coming from BT, which is another ISP, right? So BT is receiving prefixes coming from customer with private AS and advertising them towards Sprint, which is another ISP. So if you move on Sprint US now, you will see that it will start to receive these prefixes coming from, you understand, with the private AS. Now you have to configure this BT so that whenever it will advertise any prefix information towards Sprint US, it must remove private AS information from them. So for that purpose, you just need to configure only one command on BT itself. Like router BGP, it's using 35500. So neighbor, it's 101.1.1 remove private AS. Remember, this command can be configured only for eBGP neighbor, and only for that eBGP neighbor which is using public AS, not for that eBGP neighbor which is using private AS. So this time you see that Sprint US is using public AS, which is 21545. So this time after running this command, whenever this BT will advertise any prefix information towards Sprint, you will see that Sprint will not get any private AS information. You see, say clear IPBGP star in, and once again check its BGP table. My God, say clear IPBGP star. Just wait for a moment. Let it form neighborship. Once again, let it receive all prefixes coming from that neighbor. Just wait. See, they are containing only 35500, not 65500. However, they are actually originated from AS 65500. Just wait, let it define best. See, have you understood the uses of remove private AS keyword? Fine, guys. Now we are also having, like here, let me tell you something related to route filtering as well. On our one, show IPBGP, it is not receiving all those prefixes. Let me remove this prefix list from here once again. And you can also configure this prefix list in outbound direction as well, right? So IPBGP, once again you will start to receive it, right? Let me show you that how can you configure distribute list in BGP to perform route filtering. Router BGP 65500. See, distribute list, as I said that if you are configuring distribute list globally, it means it will be applied for all neighbors. And here in this distribute list, you can call either standard ACL, extended ACL, or prefix list, or you can also use gateway keyword, right? Fine, guys. This is that you can apply it. I mean, you cannot call route map over here, right? Then you can also configure distribute list per neighbor as well, like neighbor 150.1.5.1 distribute list. But here per neighbor under distribute list, you can configure either standard ACL or extended ACL only. You cannot call prefix list. If you want to configure prefix list, then you have separate keyword which is prefix list itself in both directions, like CCIE out or in. Then after, you do not have anything. So generally this method is used in BGP to perform your route filtering. Like prefix list would be configured per neighbor in both directions. You can configure it for inbound updates. You can also configure it for outbound updates as well. Have you understood it or not? So in this way, you can configure prefix list as well as a distribute list. So is it required for me to perform practicals for you here of this distribute list for route filtering? The uses of extended ACL is quite different in BGP. Only that practical I will show you, right? I will perform that practical of that extended ACL only, right? Here in BGP, uses of extended ACL is quite different. It is same as prefix list actually. The uses of extended ACL and the prefix list in BGP is same for route filtering. Like in prefix list, we can say greater than 23, less than 25, 26, something like that. I mean, we can also filter prefixes which are coming on different prefix length. Same task we can also achieve in BGP with using extended ACL as well. With using extended ACL, and let me perform that. I'll move on New York router. I'll create some loopbacks 101, IP address 90.1.1. Sorry, let me do it as 192. Loopback 102. This is 1.66 or 65 would be enough. Loopback 103, and this time 1.129, and in place of 192 I will make it 120. Loopback 104, 90.1.2.1, and last we can make it 25. Loopback 105, 2.5, loopback 106, 2.9, and in last I can make it 248. loop back 107. In place of it now I'll make it 17, and in place of it I'll take 240 108. Here I'll take now 33. Here I'll make it 224. Loop back 109. In place of 33 I'll make it 65, and here I'll make it 192. Loop back 110, 129, and here I can say 129, and in last I can say 120. That's enough. You will see on R1 all these prefixes will be present. So IP BGP. Let me show you. Fine guys, some prefixes are coming on /26, 25, 27, 28 as well, 29 and /30 as well. Let me, yes, see, it's not it. So now if you want to perform filtering here for 90s prefixes which are coming only on tell me 26 and 27. You want to filter only those prefixes which are coming on /26 and 27. So see, of course, the aggregate address for all of them will be, tell me, 90.1.0.0, and then wildcard mask will be 0.0.3.245. In it, all of them will come, but we want to filter only those prefixes which are coming with subnet mask /26 and /27. See, all of them are coming within this range, fine, but we have to filter only those prefixes which are coming on /26 and 27. So if you are taking subnet mask as 245.192, which means 26. 245.245.245.224. You just need to filter only these prefixes. So what will be wildcard mask for these subnet masks actually? Like, you do one thing, of course first 3 octets must match, so your wildcard mask will be 0.0.0 for first 3 octets, and in last octet there are changes, and I'll let you know that what will be your wildcard. And the aggregate subnet mask would also be aggregate and accordingly you have to create its wildcard mask. See, if you convert last octet into the binary, because we have came to know that what will be wildcard mask for first 3 octets, right? Because it must match. You do one thing, convert 192 into binary, so it will come 1100. Fine, 111, and all others will be 0. So we just need to match /26 and /27. We know very well that only these 2 bits must not match. Only these 2 bits must not match, and apart from it all others must match, or only these 2 bits must match. What will be? Say I want to match only 192 and 224. That's it. It means only these 2 bits must match. Sorry, must not match, and all others must match. Only these 2 bits must not match and all others must match, because it can be anything. Apart from it, all bits must remain same, so that only these 2 values will come out, 192 or 224. See, this bit must match. 1 throughout, right? 0 throughout must match. 0 throughout must match. 0 0. So it means, see, now in subnet mask you can take either this value or this value, but wildcard mask must be like, because as I said, first bit must match, so 0, then second and third bit must not match, so 1 1, then 0 0 0 0 0. So what will be your wildcard mask value now? 64 plus 32, it will become 96. So this, it should be your wildcard mask. And now see, if you type 255.255.255.192 space, this wildcard mask will work. The meaning will remain same. If you take 255, 255, 255.224 and this wildcard mask, again meaning will remain same. This time you are matching your subnet mask not to IP addresses. Just try to understand. You are matching only /26 and 27. Are you getting my point or not? You are matching /26 and 27 only. So you converted it into the binary. You see that even I will say even I will not require to have 96. See, this 1 is also matching, right?
Yeah.
We can also say that okay, it must match. So here also we can take 0.
Yeah.
The only this third bit is not matching. So in place of third bit I can take 1. So it will be 32 now. However, it will also work. See, 96 will also work. But the problem is that we want it to take only /26 and /27. So we can achieve it by using this bit only.
Yeah.
So in /26 these things will match. In /27 also these things will match, right? So now see, I will move on R1. I'll say access list 101 permit IP source. In source you have to call your prefix. So it was 90.1.0.0, then 0.0.3.245. So that all of them will come into it. Now in source you have to see this is completely different from OSPF, RAID and EICRP, because in source we were taking over their source address from where you are receiving prefixes, but here in source you have to specify your prefixes to whom you wanna permit or deny. So here I want you to deny them actually, right? So in place of permit say deny, and then in destination you have to specify your subnet mask information. So now say 255.255.292 and then wildcard mask for your subnet mask. So it will be 0.0.0.32. And then access list 101 permit IP any, then router BGP 65500 neighbor 150.1.5.1 distribute list 101 in which direction, in, as well as you can apply it for 6. So clear IP BGP star soft in show IP BGP. Wow. From that range only prefixes are coming here, but only on /25, 27. Okay, because we filtered 26 and 27 both of them. So 25 is there, so let's try 28 is there, 29 is there, as well as 30 is there.
Thank you so much, guys, for watching my video. So we'll be coming back with few more videos of the BGP. Please subscribe my channel. That's @ARC_tutorial. Thank you so much, guys. See you in next video.